Hello all. Welcome to the Digital Transformation Council's DTC Asia Meet. Today's topic is on advancing manufacturing with artificial intelligence. Next slide, please. Next, please. So the agenda runs like this. This is Ganapathy Raman, welcoming you all for the DTC webinar. And the topic introduction will be done from my colleague, Bob Hill, General Manager from Southeast Asia, based out of Singapore. We have a guest speaker who is from Philippines, Red Ramos, Director, IT Operations and Smart Manufacturing, Allegro Microsystems. After the guest speaker's presentation, there will be a panel discussion between Bob Hill and Red, and this will be followed up by audience Q&A. The whole duration of the program will be around 60 minutes. Next slide, please. Requesting all the delegates, please put your questions only in the Q&A box. Don't put it in the chat box. Please put all your questions in Q&A box. Next, please. I'll hand over to Bob Gill for the topic introduction. Bob, can you please take over?
Yes, thank you, Raman, for that introduction to today's event. So as a market research and analyst company, we spend quite a lot of time here at ARC engaged in market surveys to find out key industry trends, to measure the deployment picture of multiple automation and software technologies, and to get a pulse on current sentiments and future prospects in the industry. In one of our most recent surveys carried out at the end of last year, and which involved almost 600 respondents from manufacturing industries around the world, one of the questions we asked was, which technologies will have the most impact on your company over the next 5 years? And the top ranked technology by quite a very wide margin was artificial intelligence, quite a way ahead of others like cloud, 5G, augmented reality, digital twin. So perhaps this is no surprise to you, because even though AI has been around for more than 60 years, in fact, the landmark breakthrough in generative AI at the end of 2022 had this wider effect of reinvigorating interest in the whole field of artificial intelligence, including in existing techniques like machine learning and deep learning, as well as in the new generative aspect of AI. So when we talk about artificial intelligence here at ARC, our specific interest is industrial AI, which, as the name implies, is the application of AI technologies to realize benefits for industrial companies, to help them pursue growth, profitability, to develop sustainable products and production processes, and to achieve overall better business outcomes. Then the question becomes, okay, but where exactly are the opportunities for a manufacturing company to apply artificial intelligence? Well, in fact, there are plenty, and they exist right across the spectrum of activities you find in manufacturing, from product design, production operations, workforce management, supply chain planning, and right down to sales and service activities. And there are multiple use cases within each of these 5 categories. And I'm sure you'll hear about some of those today from our guest speaker. And certainly whenever there is a lot of hype and noise about a technology or trend, as there undoubtedly has been with AI over the last year or so, it can be very helpful to filter through all this noise and to hear from an actual industrial end user on how they see things in terms of its relevance and the potential opportunities and the benefits. So hear from end users rather than get all this information and promotional information from the suppliers themselves. So today we'll be hearing from, as Raman said, from a company in the Philippines that has, over the last few years, transformed its manufacturing capabilities to become much more of a digitally centered organization through the adoption and deployment of many advanced technologies. So with that, let me hand over to Rhett Ramos, who's the Director, IT Operations and Smart Manufacturing from Allegro Microsystems, for his presentation. So, Brett, it's all yours. Thank you.
Thank you, Bob. Again, thank you to ARC for inviting me to speak on this topic. I'm doing this not only to promote, what our company has done, but I'm a very big advocate of, as you can see in my title, smart manufacturing. And core of the smart manufacturing is really, the data and the analytics, using that data to, get insights and transform manufacturing. And the reason why I'm also doing this is, generally in Southeast Asia, it's been because of the low labor costs. It's been a very slow adoption of these technologies, and I'm hoping that, with these type of presentations, we're going to garner more efforts, more traction in the adoption of smart manufacturing Industry 4.0 technologies. So, you share my screen. Okay, so again, my name is Red Ramos. I am the Director for IT Operations and Smart Manufacturing for Allegro Microsystems. I have been with the company for more than 10 years now, and one of the reasons of bringing me on board was really to transform our manufacturing landscape from what has traditionally been, the old ways of doing manufacturing, to ushering in new technologies to really, change the game in how we manufacture our products. And again, it's been 10 years in the making, and there's still a long ways to go, but we're making good progress. I'm here to share some of the stuff that we've done, but some of the trends that I'm starting to see in manufacturing throughout the world, and in particular in Southeast Asia. Okay, so I'll first, before I go into AI, I kind of want to talk about the Gartner Analytics maturity model. And so, I'll give you an overview of why we need to go over this, and then I'll kind of talk about what is really AI, what's behind AI, and how do you enable AI? And then we'll get into the meaty part of it, which is AI use cases in manufacturing. Two of them are relatively commercially available. A lot of vendors are offering it. The last two are fairly new concepts. It's in its early stages, and some of them haven't even been implemented. And again, the purpose of this is to try to get people to adopt these type of concepts. And lastly, I'll talk about why the manufacturing companies should be adopting AIs, and some of the challenges they'll be facing when doing this. Okay, so the Gartner Analytics maturity model has been widely used in baselining and creating a roadmap for companies that want to transform their analytics capability. And you're really looking at the value that you're getting and the difficulty. So that's the y and the x coordinates. And in the bottom here is descriptive, and this is pretty much where every company is currently situated. And it's really what, right? So these are the source of your reports. And in manufacturing, they look at what was my performance last week, yesterday, the previous shift, what was my yield, what was my output. And this has been in place as long as manufacturing's been in place. And this is what you call descriptive analytics. It's really part of the hindsight, right? What happened. And then you start moving up the value chain into why did it happen? So a little bit more insight. Okay, so you get the yield. Why was your yield like this? Why was your output like this? And you kind of start getting to a little bit of a drill down and try to understand through diagnostic analytics. Then we start advancing into a lot of what people may have heard already, which is predictive analytics. And this is really when you start getting into insights, right? So what will happen. Okay, so when will my machine break down? When will when will I achieve a certain output? Okay, so that's predictive. Then the highest portion is prescriptive analytics, and this is kind of where AI starts getting into play. Prescriptive is really, how do we make it happen? What are the steps I need to do to make sure that my output is like this, or my yield is like this, okay, or my cost is like this, right? And so if you look at AI, so if the I part is intelligence, right? AI is really intended to, excuse me for a second here. AI is really intended to replace humans, the intelligence of human, right? And why we're doing this, because computers work at a much faster rate than humans. They can ingest millions of data points and decide within a few milliseconds, right? And humans can't do that, obviously. So our AI is really a broader class of systems that enables machines to mimic advanced human capabilities. And if you really break down what's inside AI, you have machine learning, which enables machines to learn from the data so it can make predictions or decisions. And you have deep learning, which is enabling machines to use data to determine actions and perform tasks independently. Okay, so now we have an understanding of AI. Let's look at how AI is used and can be used in manufacturing. So the first case, so I'm going to talk about a bit of a history of some of these use cases. So product quality inspection, right? Every manufacturing company has to inspect their products before it goes out the door. And the old way of doing it is through human eyes, right? So very tedious, very time consuming, could introduce lots of mistakes. Humans, if you're working 8 hours, 12 hours a shift, you can run into fatigue, your eyes can fail you, so you could have some quality escapes. And the output is also not predictable, so humans can get really energetic at the start of the shift, but then get bogged down due to fatigue, and so the rate of inspecting may go slower. But then you start introducing some replacements of human, which are cameras, right? And this is where you get into machine vision. So you're using cameras to quickly inspect products. They do it at a much faster rate because it's software based. So they take images and then they determine whether the image of that product conforms to their quality standards. And so how machine vision usually works is you have to teach a camera. You have to reference. So for example, if your product is this little board here, you have to feed the camera images of what good looks like. Okay. But then you also have to feed the camera images of what bad looks like. Okay. So in my example here, you could have a defect here, or a defect here, a defect there, a defect there. Now, this is what the camera does. So it looks at your image, then it compares it. Does it look like a good one? Or does it look like any of the bad ones that I'm supposed to compare it with? That works really well. And you can get up to, in some cases, machines can inspect products at a rate of 8 products per second. Okay. So that's about, I'm sorry, 12 products per second. A rate of, the fastest I've seen is running at 8 milliseconds per product. You can do it really quick, whereas a human may be able to do it in, at the fastest, one product per second. But then here's a scenario where there's a defect that has not been learned before or has not been experienced. So what does the machine vision do? Or the quality inspector, the machine that does the quality inspection, do? Well, there's 3 likely scenarios, right? The first one is the equipment stops and say, okay, operator, please make a disposition. Should I, mark this as a defect, or should I, mark this as a good product, right? The second scenario is, okay, I'm going to compare this to the bad ones. And it's not in my reference bad images, so I'm going to mark this as a good. That has really big ramifications because you could potentially be shipping out bad products, right? And that's happened in some companies, including Allegro. And then the third scenario is the opposite, where it references the good images and say, okay, that's not part of the good image, therefore it must be bad. Now, it's not, the consequence is not as grave as your second scenario here, but what this ends up is that you're throwing away parts that should be good, right? So it's not affecting product quality, but it is affecting your cost. Now, with AI, the scenario here is that you don't know what to disposition. AI, because it has machine learning and deep learning, when you feed that, it looks at, it makes a decision, and it can decide whether it's bad or good within the 8 millisecond time frame that I had mentioned. And so you're gaining the speed, you're not sacrificing the speed, but you're dispositioning the products properly. And we've also had situations, and particularly in Allegro, where AI is overturning so we have software AI that looks at the defects that have been categorized by your machine vision and have overturned those defects because it knows it's not a valid defect. And in some cases, we've had of the rejects, we've had about a 91% gain in yield from those defects. Okay, so for example, if there's 100 defects, we recovered 91 of those defects and have shipped those. So instead of reproducing those 91 units, we ship those 91 units out because they are good parts. And so that's the benefit of AI in machine vision. The second case, again, the first two cases I'm going to talk about are what's commercially available already. The second case is how you move parts, how you move material in the shop floor. And your traditional way of doing it is through a push cart, pushed by humans, obviously, right? A lot of companies still do this. And so don't be surprised if, when you go into a shop floor within Southeast Asia, that they're still using this because labor is cheap, right? So, but they're starting to realize, and you're starting to see some warehouses adopt what you call automated guided vehicle. And the way automated guided vehicle works is there's a guide, be it these strips here or these lines. But the downside, the good thing is these things move automatically. The downside is you limit your flexibility because these AGVs only follow the lines. So if you, for example, relay out, you have to relay out these lines so that these AGVs follow. Okay, and so it's very simple. Just think of it as a train following a railroad track, right? So you have to build that railroad track for the train to follow. Similarly, these AGVs, you have to build these guides for the AGV to follow. The where AI comes into place is where you come in when you're using autonomous mobile robots, and I'm using an example here of an AMR from a company called Teradyne. They have a division called Mobile Industrial Robots, MIR, and I'm just showing you a video so that you have a better understanding of what it does. I'm not in any way advocating or sponsoring this, but I am showing you an example so that you have a better understanding. So these AMRs have cameras, have lasers, and what it does is you launch this into your floor and you guide it, and it'll map out your floor, and it now understands what your shop floor looks like. And so these will be docked. These mobile industrial robots are typically docked in a charging station. And when you trigger it, when you call it to pick up some material, it will determine the best route to get to you or the fastest route. And so there is no need for a guide. it's just like a human, right? So you're telling somebody, can you come pick it up? That human being will then decide, okay, I'm going to make left here or right here. Now, if there are obstacles in the way, this mobile industrial robots will move around it, or if there's a human in the way, or for example, if there's some constructing happening on the shop floor, it is intelligent enough to know that, okay, I need to avoid this area because there's a challenge to getting to that area. And so this is really where AI comes in, is on these mobile industrial robots. And then when it's done, it goes back to a charging station again and charges the battery. The third use case is we're now getting into some really unique concepts here, because I haven't really seen these practices being adopted in manufacturing here in Southeast Asia. Now, a little bit of on the equipment maintenance. So there are some companies that have already adopted this type of technology, which I'll show. Okay, so again, in the same manner that I'm showing you in the previous examples, I'll show you how it's done now, which is typically there's what you call preventive maintenance, PM, right? It's called PM. But the PM has now evolved into what you call predictive maintenance. But then there's another evolution of that PM called prescriptive maintenance. And the difference is, in preventive maintenance, it's usually time or unit based. So think of it as of your car, bring it to the shop every 3,000 kilometers or every 3 months. And then they perform standard work. Like they'll change your oil, they'll change your aircon filter, this. Doesn't matter whether the oil needs to be changed or your aircon filter is still good, but it's part of the standard work that you need to do at your 3,000 kilometers. Predictive maintenance, on the other hand, looks at the condition of your car or the condition of the equipment, and then dictates whether it needs to be maintained or not. The work, though, is still the same. So again, think of your car, right? So you're not having to bring your car to the shop every 3 months or every 5,000 kilometers. You need to bring it to the shop when the car tells you to bring it to the shop. But the work that's being done is still the same as what the work that's being done in preventive maintenance. Prescriptive maintenance, on the other hand, is a bit more precise in that it knows which item needs to be fixed. So it's still looks at different parameters, and it will trigger you to bring your equipment for maintenance, but it prescribes which item needs to be repaired or maintained. Okay, and in some cases it can also adjust parameters. So for example, if you are expecting it to be running, and let's just think of a motor running at 1,000 RPM, but then it knows that if you continue to run at 1,000 RPM, that motor is going to degrade over time. It's going to slow down. Now you're not getting the same throughput, but you're extending the life of that motor. And so that's another version. That's another version of prescriptive maintenance, is automatically adjusting the parameters. So the benefits of your preventive maintenance is, yes, you're keeping your machine at the optimal condition. So it's not going to break down because you're performing regular maintenance on it, just like your car. The advantage of predictive maintenance, of preventive maintenance, is that, yes, you're getting the optimal performance, but at the same time, your equipment availability increases, because anytime the equipment is not producing something, meaning running parts, it's adding to your cost. Okay, so think about your car. If your car is in the shop, you can't use that car, right? So instead of bringing your car every 3 months, you're only bringing it maybe once a year. So you've gained those 3 extra periods that you would have brought it if it were a 3-month maintenance schedule. So the same applies with manufacturing equipment. And some of these are multi-million-dollar equipment, so it's very critical that they are producing parts, at the highest uptime. And then with prescriptive maintenance, you're kind of gaining the same thing as predictive, except it's more cost effective because it is prescribing which parts to replace or to maintain. Again, if you look back at a car, with prescriptive maintenance, you're not having to change the oil and change the filter, or put some change some parameters. You're only having to change the oil because that's the only thing that needs to be changed. Okay, so that is prescriptive maintenance. The second use case of event prediction, I kind of have to go through for some of you who may not be familiar with semicon manufacturing. Let me kind of give you an overview of how it's typically done. And all semiconductor companies do this. They have wafer probe and test. So the items here in green are your manufacturing areas, and the items in kind of teal, bluish teal, are your inventory areas. Okay. And material movement usually goes from left to right. So you start out with a wafer, and then it gets probed or tested, and then it becomes what you call die. So these are the individual squares you see here. Okay, and then each die or the wafers are then launched into assembly, and out of assembly is a chip. Okay, then these chips have to be tested again because the customer may have a specific use case for that, and while they're here in wafer probe, there is no specific customers who have ordered that yet. So you have a forecast, but nothing specific as to how they're going to use that. Also, you're testing in final test defects that may have been introduced in your assembly process. So you have to undergo a final test before you mark it and then put it in a reel to go to your finished goods, and it's shipped out. Now, typically, most semiconductor companies will have an expected yield at each WIP sector. So the green is a WIP sector, and these are operations within that sector. So for example, wafer probe and test may have an expected yield of 98%. Assembly will usually have higher yields because these are mechanical defects, not necessarily defects of the product or defects introduced from a wafer fab. And then final test will depends on the maturity of product. 96% is acceptable, and then you'll have some yield offs here because maybe there's a mark that happens that shows you the final product, and that there are some defects in the mark. That's why you have the vision systems inspecting these things. And so if we were to look at the scenario where you have 5,000 units in a wafer, and that wafer is launched into wafer probe and test, and your expected yield is 98%, you're going to receive 4,900 units at die bank. And then you assemble it with an expected yield of 99%. You're going to yield out about 4,851 units. Then go through tests. You're going to be testing them, and then you're going to have some further losses, and then further losses. And then when you reach finished goods, you're about 4,500 units. So you lost about 500 units from where you start. That is okay. That's normal in semicon manufacturing, right? But if you have AI-based defect prediction, the scenario, again, if you had the same shop floor, you could have an AI system running in wafer probe and test. So let's go through that same scenario again, where you have 5,000 units. So because of 98% yield, you should be producing about 4,900 units. But your AI system is looking at, of those 4,900 units, how many of those eventually fail at final test? So it's going to go ahead and mark down the yield. Therefore, it is going to add more defects. These 100 units are going to fail at final tests anyway. So instead of 4,900, I'm only going to produce 4,800 units here at final test. I'm sorry, at a wafer probe. And then it's going to go through its normal 99% assembly based defects with 4,700 final test. Now, final test has now increased because you've already yielded out those units here in wafer probe. Hence, you're producing the same number of units in final test, going through your 98% yielded finish, and again, producing the same number of units at finished goods, which you eventually send to your customer. So people might say, so what advantage do I get? I'm still producing the same number of parts, right? Well, you've reduced the material that you've used that you would have built at assembly, because you've already yielded those out at probe. And you've also increased your equipment utilization, because those 100 units that you would have used on the equipment to test those units, which are bad, could be used to test 100 good units as well, okay, for maybe a fresh batch. Okay, so there are two advantages, big gains, is that and you know, it seems small at 5,000 units, but when you are starting millions of units per week, that number could be very huge. Okay. And then the fourth use case is floor optimization. So if I were to look at how planning and scheduling is done in most manufacturing companies, you have a demand from your customer. You have a human-based production planner that looks at the demand, looks at what's happening on the shop floor through reports, excuse me, and then trying to figure out a plan. So they will release that production plan on the shop floor. If all goes well, the production plan is followed, but we all know not everything goes well in production. Equipment breaks down unexpectedly. You have some changes. You have you know, some manpower changes. Maybe a few of your operators aren't able to come in during the day. So those changes have to be comprehended. But you have a human again that's having to comprehend those changes and then revising the plan for production to follow. And again, humans are a lot slower than computers, and humans will make mistakes. So there have been instances where plans, the revised plans, or even the original production plan, are incorrect, because maybe there was a copy paste issue. They were using Excel to plan, and they copied the wrong row or the wrong column or the wrong value. So that's a typical scenario that's happening in the production planning process now. Now you have what you have software that's commercially available called advanced planning and scheduling. This software mimics what the production planner does, but you have to define those rules at the outset. Okay, because production planners, they look at the rules. Okay, if it's the demand from this customer will get this priority, therefore I will plan that first in front of the other customers. Those type of rules, and for example, there are lot combine rules, like, oh, I can't combine lots if they're a few weeks apart in manufacturing. So those rules have to be comprehended by your APS. It creates, now the advantage here is the plan is more accurate. It depends on the integration as well. So if you have a manufacturing execution system integrated to your MES, into your APS, that it's getting that the production status directly from the systems versus relying on reports and having to copy paste. If there are changes, it also depends on how often your APS software works. My experience is APS software is not real time. So if there are any changes that are happening on the production floor, it can only be comprehended on the next shift when your APS software runs again. Okay. So yes, the quality of your plan is better because you're getting it directly from your systems. And it's faster as well relative to the human production planner. But the rate of change, or the rate of applying that change, is a lot slower because this is not running in real time. Now, we have seen AI-based, they're not even advanced planning and scheduling software. It's an AI tool that looks at all of these. Again, because of deep learning and machine learning, it can ingest millions of data and make decisions quickly. Therefore, you could have instantaneous changes to your plan happening as changes are happening on the shop floor. So the moment your equipment breaks down, and if you have a automated fashion of capturing that status, that could be comprehended immediately by your AI and say, okay, let me reroute some of the lots that I was planning on having it run on that equipment to this other piece of equipment that may be idle. Okay, so that is the advantage of AI-based planning and scheduling. Okay, so those are the 4 use cases of AI. There are quite a few more, but I don't have a lot of time to go through all of them. So I thought I'd just go over 4 use cases. So some of the challenges that, AI is not just like a piece of software they implement and turn on a switch and say, okay, now I'm running AI, right? So AI, again, is only effective if you have the right data, right? And well, you have data and you have the right data. So if it's garbage data, you're going to have garbage insights from your AI, right? So it relies on high quality data. Again, the challenge in a lot of companies is the lack of clean, structured, and application specific data needed for reliable insights. And this is especially true in areas like quality control, where incomplete defect data can impact model accuracy. Okay. Another issue that's keeping us from adopting AI much faster is the shortage of skills. Okay, there's a scarcity of professionals with expertise in AI, data science, and machine learning. It makes it more challenging for companies to fully utilize or implement AI without investing in workforce development. And there's also cybersecurity concerns because AI requires a lot of integration. So you could be opening up areas where there could be cybersecurity leaks because, again, you are relying on more connectivity. Okay, so manufacturers need to adopt advanced cybersecurity measures to protect sensitive systems. And AI is not cheap. Okay, so it requires a large upfront investment in technology and infrastructure, and it could be a barrier for small companies. Okay, and the big thing, and I think is, I put it specifically in the bottom here, is change management. People are always fearful of AI, right? They think, oh yeah, they've seen the movie Terminator and they think the robots are going to replace us or kill us, right? That's not always the case. I mean, when they started implementing ATMs, people thought that they no longer will need to hire tellers, but tellers still exist. The ATMs only allowed banks to give access to users on a wider scale, right? And so I think that's the message that we ought to relay the workforce is it's not here to necessarily replace you. It's here to replace some of the repetitive tasks that you're doing, some of the non-challenging tasks that you're doing, and can do it faster with higher quality. Okay. And lastly is I want to end with a high note. So what are the benefits of AI in manufacturing, right? So there's increased efficiency. AI-driven automation accelerates production, as you can see in my previous example, because it takes over a lot of repetitive tasks. It reduces human error and optimizes workflows, right? Because systems are integrated, processes become more streamlined. From raw materials to finished products. Okay. There's also cost reduction with automation, predictive analytics. You improve the quality control, which contributes to your cost. It can also reduce labor, and as you can see, it reduces maintenance, right? Maintenance expenses in particular. It can also potentially save on waste and energy consumption. Okay. And then, of course, it improves decision making. It processes data in real time and now empowers managers to make informed data-driven decisions. And so one example is a digital twin, which I didn't cover, but that's another use case of AI. Okay. Okay, well, that concludes my presentation. I think we're gonna go into a panel discussion or a roundtable, and then. But if you do have questions, this is my email. Feel free to email me if you have specific questions to what I presented or what Allegro is doing provided I can share it to you.
Yeah, sure. Yeah, thanks very much, Rhett, for that very fascinating presentation. Yeah, you're right. We are going into the Q&A segment of this event. So please do put your questions in the Q&A box. And I already see we already have quite a number of questions coming in, which is good. But let me kick off the session by perhaps asking a couple of my own, if I can. So you mentioned, Rhett, that you've been evolving the company over the last 10 years into much more of a digital organization. So, but you also mentioned things like, labor cost is still relatively cheap in Southeast Asia. So I'm interested to know, what were the key drivers that motivated Allegro to develop advanced manufacturing capabilities?
Sure. So there's really two that I can just sticks out. One is our continuous improvement drive, right? So you always want to see what else can you do to better your manufacturing facility, and really, we've addressed the quality concerns. Not me, but Allegro previously, and so they thought that let's introduce the digital floor to further advance our manufacturing capabilities. The second one is really the type of business we're in. We're a sensor company, okay, and a lot of the parts that we produce go into cars, and
Okay.
there's a lot of emphasis in making sure that the parts that we put in these cars work, and they never fail. And when you have humans manufacturing these parts, they will fail. We've improved the quality. Yes, we used to measure our defects in parts per million, but because of digitalization, we're now measuring defects in parts per billion. Okay, so yeah, it's really, I guess I think that's probably the biggest one. Is we're an automotive company, and we don't want you driving these cars and these sensors failing, right?
Yeah, not really. So I think another thing you implied was that Southeast Asia and other parts of Asia are a little bit behind in terms of advanced manufacturing and deployment of newer technologies. So within Allegro itself, what was the existing level of knowledge of those digital technologies, and how did you acquire or increase knowledge within the company itself about the potential of these new technologies?
Okay, yeah, I was brought on board I'm still part of IT, and I was brought on board as part of the IT organization. And IT typically are not very well versed in manufacturing, right? I was fortunate because I didn't start my career in IT. I started in manufacturing, so I kind of used background to help Army in digitizing our manufacturing floor. So that was it started with me, but I also had to rely on vendors, on external experts to bring in the knowledge to help implement systems. But then we utilize their knowledge and train in-house the workforce that's responsible for digitizing our shop floor. Now, we're not fully autonomous. We continue to rely on vendors because there are vendors that do this for a living. Our business is not in equipment automation. Our business is not in AI. There are companies that can provide you those solutions. There are some companies that can provide AI solutions specific to semiconductors, which is a far cry from what we had 5 or 6 years ago. We had companies that provided AI solutions, but they're very generic, and you have to have the subject matter experts tweak it. But we now have companies that, again, can say, okay, this is really specifically built for semiconductor back-end manufacturing.
Right, okay. And for Allegro as a whole, in terms of the whole organization, are you looking at AI broadly across the company, or is it just in manufacturing right now?
So it's the latter. As a matter of fact, the AI journey started outside of manufacturing.
Okay.
We were fortunate to have brought in someone that worked for an AI company, but you're also seeing the commercial availability of AI, right? Microsoft Copilot, Chat GPT, right? And so those are used in, getting your policies. If you have a question about a policy, you can utilize Copilot to do that for you. But within manufacturing, it's a bit slower because there are specific steps. Again, it really depends on the quality of your data, right?
Yeah.
And data is not there. If the data is not structured properly, you have to do that first before you put in your AI. And that's really why we chose not to implement that in manufacturing. But before that is really accessing the data. So if you don't have automatic access to that data, if you're having to rely on Excel or worse log sheets, then there's no way you can implement AI.
Yeah. So having data itself and having good quality data is absolutely key. Then okay, I think let's go to some of the questions that I see coming in today from our audience out there. And the first one is actually about data. The question is asking what type of data needs to be collected about the machine, say a semicon machine, to feed the model to allow AI-based prescriptive maintenance. So what type of data are we talking about typically?
Okay, so it really depends on the type of equipment. Okay, I mean, okay, so let me be a bit more generic first. Any piece of semiconductor equipment on there has a motor. Okay, so the motors will eventually break down, and how companies monitor these are the vibrations of the motor. They look at the temperature of a motor, and because of course, if it overheats, then it's likely to break down, right? So these are the data that's typically monitored by companies that offer predictive maintenance for equipment. There is one specific vendor that provides a predictive maintenance tool that's not specific to semiconductors. They say, okay, we can monitor motors, we can monitor the tracks, because those exist in any piece of equipment, and we can tell you when the equipment will be breaking down.
Okay, sure. There's a question here about the machine vision segment of your presentation. Basically, the question is asking, I want to understand more about how training of the AI model takes place, because in manufacturing, it's not possible to understand all of the possible abnormal conditions we may come across.
Yeah. Sure. And yeah, that was exactly my example, right? Is you have this defect that you've never seen before. So what do you do, right? And AI, I'm not an AI expert, okay, but there are models that says, okay, run these algorithms and determine whether that should be good or bad. That's how the ones we're using are supplied by our vendors, so I don't know what happens under the hood, but that is basically how they're doing it. Is they have something that can learn quickly, and based on thousands of data points, images that they've seen before, it can determine whether it really is a good part, even though it looks bad, or vice versa. It really is a bad part, even though it is a bad part.
Right. So the point is, you don't have to understand all the abnormal conditions, because the model will learn those. I think that's the idea.
Exactly.
Yeah.
Yes.
Okay. Another aspect you touched on towards the end of your presentation was on change management and the importance of change management. And the question we have here is about how this can be a very difficult topic, even in the white collar world as well as the blue collar world. But so what suggestions would you have to mitigate this issue like AI is coming in, and how do we make people on the shop floor comfortable with the fact that it's not going to destroy their livelihood? Do you have some suggestions for managing this change process?
Sure, it starts with the message, right?
Right.
I mean, the moment you say AI, they're gonna be suspicious of it, right? So you start out by saying, we're gonna help you, right? So I need your help. So if you get them involved, they're more likely to be cooperative in implementing that technology. If you say, hey, what are some of the challenges you're facing, and how can I help you face those challenges, right? How can I help? How can I use AI to help you overcome those challenges so that you don't have to have, your work will be a lot easier, or you can do more higher value work. And that's what we did with operators. We told them that, hey, you know what, a lot of these things that you're doing are non-value added. They are very cumbersome. It's not part of your job. You as the operator is supposed to operate. You as the operator is not supposed to make a decision whether you should do this or that. You have what you call work instructions, and work instruction is very specific. Do step 1, step 2, step 3, step 4, and you do it every time. At no point should be you diverge from that one. And so if you have the tool to remove that one, they can do 1, 2, 3, 4 every time, which makes their job easier. And we've surveyed them after implementing these technologies, and they are so thankful that these technologies are there, because it improves their throughput, but also it improves the quality of their life, because they're not stressed out, because the burden of them having to make these decisions are no longer on them. And so you have happier employees. So it really starts with the message and getting them involved. You don't come in and say, hey, you know what, this is, I'm the new kid on the block, we're going to implement, right? It's really, hey, let's help each other here.
So what's in it for you, and how are you going to benefit? That will help go a long way to ease fears about the deployment. I think that's what you're saying. Okay. Okay, let me look at this other question we have. I think that with a lot of trends and initiatives that we see happening in the industry, there can be sometimes confusion or perhaps fatigue about, okay, something new. How is it going to be different? So the question is, how does AI in manufacturing, how does it, what's the connection between that and Industry 4.0? Are these two different things? Is it a complement? And I know you've talked before about Industry 4.0 in some of your previous work. So where do you see this relationship between AI and Industry 4.0?
Well, it's a subset of it.
Right.
So if you go through, what Industry 1 was, introducing machines to do the work of humans. Industry 2 is being able to mass produce because you have electricity. Industry 3.0 is, okay, putting in sensors, putting in PLCs so you can automate. Industry 4.0 is adding a data element to it and having making decisions, automatic decisions based on the data. And that's what AI is it's using the data that you already have and making those decisions for you. So it is part of Industry 4.0. As a matter of fact, I think it is what makes Industry 4.0 different from Industry 3.0.
Okay. Okay. Hope that clarifies that point. Question about legacy systems. How do we address the challenges of integrating AI solutions with legacy older manufacturing systems, and also scaling AI applications across complex production environments? So I guess two things there about legacy, and also how do we scale these AI applications?
Okay, so when I guess when they say legacy, it's not being able to connect to the equipment.
I guess so. I guess,
right?
or
So,
difficulty.
I mean, there are solutions out there. You can add sensors to be able to read what's happening. simple Arduino board that you can put on there with motion sensors to see how many units have been processed. That's data already that you can be arming your AI, right? So that's one approach. There are companies that specialize in this. For example, in semicon, we have a equipment communication standard called SexGem. Okay, and this is the standard we use if you want to if you want to be able to connect the equipment and talk to it. You use the SexGem protocol. Legacy equipment didn't have that one. There are companies that can provide SexGem connectivity, and I'll name one specific method. Is they capture the screen and they look at what's happening in the screen, and they know, okay, you're changing your recipe, for example, or you're changing this parameter. It also captures your keystrokes, and what it'll do is it will then, because it's connected to your computer, it will then mimic those keystrokes. So if you say I need to type Bob Gill, it'll type Bob Gill for you. And it does, but it's connecting, the SexGem again is connecting the equipment to your automation system. And so it allows you to connect using SexGem. Okay, so could you excuse me for a second? Getting a call.
Oh, sorry, Rhett, I think we've lost. I think we've lost you. We can't hear your voice, Rhett. I think we've.
Bob?
Yes, we got. You're back now. Yeah, you're back.
Yeah, I got this question from you. So how do you scale it? Well, it depends. So if you, for example, adopt standards, so there is a platform right now to measure smart manufacturing adoption, and I believe it started in Singapore, called SIRI. SIRI is Smart Industry Readiness Index. And with SIRI, they look at, there's 16 dimensions that SIRI looks at. One of them is, are you standardizing? If you standardize, then, for example, SexGem, if you're using SexGem, then you can easily scale your AI adoption, because the way you talk to this one piece of equipment is the same way you talk to this other piece of equipment. So that's really how you scale if you adopt standards. And that was, again, Bob, if you go back and ask why we haven't fully adopted AI in manufacturing, is because we have to adopt those standards first so that we're able to access that data. But then once we have access to that data using the same standards, the AI solution for this area can also be applied to this other area.
Okay. All right. Okay. Okay, let me take probably is like to be one of our final questions about how easy or fast is it to implement an AI solution like for machine vision, say now compared to say a few years ago. Is it becoming easier, or we require less time to train the model? What are your thoughts on that?
Well, I've only done it once. I have no reference.
Sure.
Yeah, so I can't say it was easier then, because we only did it like a year ago.
Right. Okay.
It was a commercial solution that was offered to our vendor, but it took about a few weeks.
It took a few weeks. Okay,
you're not changing anything, because what you're doing is you're using your existing vision camera, but then you're adding an AI layer behind that one. So whatever image your vision camera captures, your AI then will determine whether it's good or not. And again, it does it within a few milliseconds. So you're not really drastically affecting your throughput. Okay.
And finally, so you said, I think one of the things you mentioned was you've done quite a lot at Allegro, but you still have a long way to go. So what are some things we can expect from you in terms of your manufacturing capabilities? Where are you going to next? I know AI is part of the program, but can you give us just a brief idea of that?
Yeah, so we have a lot of data. So we want to start using that data to improve our products. Because there's such what you call a digital twin. And typically digital twins are more on seeing what's happening in their shop floor real time. If this equipment breaks down, you can see it immediately, right? but we haven't really applied digital twin technology in predicting how a product will perform in manufacturing before it gets into manufacturing, right? And so you can look at, okay, so you have a new product. It typically what they do is they release it as a new product, but it's not scalable to manufacturing yet. So you have what you call an NPI process, new product introduction process. And what they do is they qualify that over several pieces of equipment so that they know that if that product runs any equipment with different combinations of hardware, your yield triggers or your yield expectations are going to be met. Okay, but that's a very long process because you have to run it this piece of equipment, that piece of equipment, and if you have 10 pieces of equipment, you have to run in 10 pieces of equipment. And that, by the way, that process takes up production time because you're having to use production equipment. So what we're looking at is, can we do a lot of that stuff up front without, utilizing equipment? Therefore,
Right.
you're increasing your equipment uptime. And really, the final final validation is just done on the equipment, just to make sure that your models are correct. And just like with any AI model, they have to be tweaked, right? So at least bulk of the work can be done offline through simulations or it's run on a piece of equipment. So we're looking at that one.
Okay, great, and it's good to see you're looks like very enthusiastic about things you've done and the things you still have to do at Allegro. So that's really good to see. And I think I like the aspect where you say that in Southeast Asia we really need to get ahead and do more in this region. So that's good. That's good to hear. Good to see that companies like yours are moving ahead at quite a good pace. So with that, I want to thank give my thanks to Rhett for his absolutely fine presentation today, and to our audience for all of the questions that I see coming in. I apologize if we didn't get to tackle all of the questions, but you did see Rhett's emails earlier, so please do feel free to contact him directly. And let me now hand over to my ARC colleague, Lena, for the closing.
Thanks, Bob and Rhett. It was a great presentation, and thanks for moderating. I have an upcoming physical events announcement. So our next DTC Digital Transformation Council Asia Online will be announced soon. And we are having an upcoming event on Asia Forum, that is from Bangalore to Singapore. That Bangalore, India, we have on 10th and 11th July. Tokyo, Japan event is on 8th July and Singapore event is on 7th July. So if anybody is interested to attend or participate, please get in touch with us. And we have Europe Forum, European Industry Leadership Forum is also scheduled on 5th to 7th in May at Spain. And we recently completed our ARC Industry Leadership Forum in Orlando, US, America. So we would like to thank Rhett Ramos, Director IT. And also, I would like to thank Bob Gill for moderating the session, and thank India team for all the other logistics. And also thank all the audience who had participated today. And we will be sharing you the video of this session shortly. Thank you all.